Somewhere out there, hidden across the universe, are materials so rare that all the gold ever mined on Earth would look worthless beside them. Some exist for less than a heartbeat before they destroy themselves. Some are buried in the hearts of dead stars, crushed beyond anything you could imagine. And one of them is so valuable that a single gram would cost more than the economy of an entire planet. These are the 12 rarest materials in the universe. And the closer we get to number 1, the stranger they become. Number 12, Francium. At any single moment, scientists estimate that less than 30 grams of natural francium exist in the entire crust of the Earth. Not 30 grams per person, 30 grams on the whole planet. It is an element so violently radioactive that it tears itself apart almost the instant it is born. If you somehow gathered enough of it to see, the heat from its own radiation would boil it away in front of you. No human being has ever held a visible piece of francium, and no one ever will. Number 11, Astatine. If francium is rare, astatine barely exists at all. It is the rarest naturally occurring element on Earth. At any given time, the entire planet holds less than a single gram of it, scattered atom by atom inside other rocks. It is so unstable that scientists have never been able to gather a visible sample. The moment you assembled a chunk large enough to look at, it would instantly vaporize itself in a burst of its own radioactive heat. We know it is there. We simply cannot hold it. Number 10, Oganesson. This one does not even occur in nature. It is a super heavy element built by humans one atom at a time by smashing other atoms together inside enormous particle accelerators. Creating just a handful of atoms can take months of work and millions of dollars. And the reward, each atom survives for less than a thousandth of a second before it falls apart again. It is one of the heaviest things ever made and one of the most fleeting. Blink and a lifetime of it is already gone. Number 9, metallic hydrogen. Hydrogen is the lightest and most common element in the universe, but squeeze it under pressure millions of times stronger than the air around you and something incredible happens. The gas collapses into a shimmering, silvery metal. On Earth it is almost impossible to create and even harder to keep, but scientists believe it forms naturally, deep inside the crushing cores of Jupiter and Saturn. It may also be the most powerful rocket fuel physically possible, able to change space travel forever if we could ever learn to hold onto it. Number 8, the Bose-Einstein Condensate. To make this, you take a cloud of atoms and chill it to a fraction of a degree above absolute zero, colder than the deepest void of space. At that temperature, something bizarre happens. The atoms stop behaving like separate particles and begin to act like a single object, blurring together into one. In this state, matter can flow forever without friction, creep up the walls of its container on its own, and scientists have even used it to slow a beam of light and bring it to a complete stop. Number 7, time crystals. For a century, we believed a crystal was something that repeats its pattern in space like a snowflake or a diamond. Then, only a few years ago, scientists created a completely new form of matter that repeats its pattern in time. A time crystal ticks endlessly in a perfect rhythm. And here is the part that should not be possible. It does this without ever using or losing any energy at all. It is the closest thing we have ever built to true perpetual motion, a structure that could keep ticking long after the last stars have died. Number 6, Quark-Gluon Plasma. This is the oldest material on this list and the most extreme. It is what the entire universe was made of in the first fraction of a second after the Big Bang. Before atoms, before protons, before anything solid existed, there was only this. A blistering soup of pure particles at trillions of degrees, the hottest substance that has ever existed. Today, we can recreate it for the tiniest flash by smashing gold atoms together at nearly the speed of light, briefly reopening a window into the birth of everything. Number 5, white dwarf matter. When a star like our Sun finally runs out of fuel, it does not explode. It collapses. Gravity crushes the entire star down to roughly the size of the Earth, packing the mass of a sun into a ball you could lay between continents. The matter left behind is so dense that a single sugar cube of it would weigh as much as a car. And over billions of years, that crushed core slowly cools and hardens until the dead star becomes, quite literally, one gigantic crystal of carbon, a diamond the size of a planet. Number 4, neutron star matter. Now take that crushing force and push it to the absolute edge. When a star far larger than ours dies, gravity does not stop at the size of the Earth. It keeps going until even the atoms themselves are shattered and protons and electrons are squeezed together into pure neutrons. The result is the densest material in the known universe. A single teaspoon of neutron star matter would weigh around 1 billion tons. That is more than the weight of every human being on Earth, combined, balanced on a spoon. Number 3. Strange matter. Now we leave the world of the confirmed and step into the world of the terrifying. Strange matter is a theoretical substance that some physicists believe could be even more stable than ordinary matter, and that raises a chilling possibility. If a single speck of strange matter ever touched normal matter, it might convert that matter into more strange matter, which would then touch more and more. A silent, unstoppable chain reaction that could, in theory, transform everything it meets. We have never found a confirmed piece, and perhaps that is a good thing. Number 2. Dark matter. This may be the strangest entry of all because it is everywhere and we cannot see a single piece of it. Dark matter makes up the vast majority of all the mass in the universe. It is the invisible scaffolding that holds entire galaxies together, stopping them from tearing themselves apart as they spin. And yet it does not glow, it does not reflect light, and it passes straight through you, through the Earth, and through entire stars without leaving a trace. We have spent decades building detectors deep underground to catch just one particle of it. So far, we have caught nothing. And finally, number 1. Antimatter. For every kind of particle that makes up you, the stars, and everything you have ever seen, there exists a perfect mirror image carrying the opposite charge. That mirror is antimatter. It is the single most expensive substance human beings have ever created. To produce just 1 gram of it would cost an estimated $62 trillion, more than the value of almost every economy on Earth put together. And the reason is as simple as it is violent. The instant antimatter touches normal matter, both are annihilated completely, vanishing in a flash of pure energy. It is the rarest, the most valuable, and the most powerful material in the universe. From elements that vanish before you can even see them to matter that could rewrite reality itself, the universe is hiding substances far stranger than anything we could ever invent. And we have only just begun to find them. So the real question is this. If you could hold just one of these in your hand, knowing exactly what it could do, which one would you choose?